Sorry about yesterday's break in transmission. This is recording just to go through what I was supposed to go through with you guys yesterday. So, I'll be taking you guys to build a decentralized application on Metis, and what what I'll be doing is that I'll be helping you guys learn about Web3 development for those who are new to Web3 development and how to build a decentralized application on Metis. Just going to skip through that. So, what is Metis? Metis is an Ethereum virtual machine compatible blockchain that uses optimistic rollup to scale Ethereum and focuses on decentralized applications on real world use cases for real world use cases. So, what this is saying is that Metis is a type of a layer 2 scaling solution and leverages innovative technologies such as optimistic rollup, decentralized sequencers, option storages, and for example, and for it uses it for empowering sustainable Web3 economy. Metis is designed in a way that prevents single points of failure issues, which is a problem that most layer 2 scaling solutions suffer from. Uh, Metis has a lot of features, which includes a decentralized ecosystem governance, a secure network, low gas fees. It offers faster transactions, and it allows developers to build on an easy to code blockchain. So, Metis has an easier onboarding interface, simple integration, scalable infrastructure. So, these are the features that Metis provide. And I also need to mention that Metis is the first optimistic rollup that has achieved sequencer decentralization, which eliminates single point of failure, and it aligns it aligns incentives between all network participants. I'm going to explain what sequencer decentralization is later during the course of this video. So users, developers, and enterprises can benefit from Metis features, and not only just developers, businesses and organizations can also benefit from Metis. Metis has introduced a unique concept called decentralized autonomous companies, which goes beyond the traditional DAOs. DAOs is decentralized autonomous organization. The autonomous companies is built to encourage businesses and community to build and manage their operations on chain. So Metis provides framework for collaborative decentralized projects, combining blockchain governance, management, and collaboration tools all in one platform. So now I'm going to explain what uh, Web3 is for those people that are new to using. So what is blockchain? On the slide, I have two definitions, and I'm just going to read that out. Oxford says blockchain is a system in which a record of transactions made in cryptocurrency is maintained across several computers that are linked in a peer-to-peer network. Investopedia says blockchain can make data immutable and reduce the need for trusted third parties. Now, in my own terms, blockchain from the word blockchain, block and chain. Blockchain means blocks of transactions that are linked together in a chain, forming a distributed database. So it is majorly a database. And in a blockchain, each block contains a timestamp and a link to the previous block, which creates a secure and tamper-proof record of transactions. Blockchain is a decentralized network, which means that no single entity is in control of it. No, a single party is not in charge of the transaction data, and it is immutable. That means that it can't be altered, it can't be deleted. Once a transaction is posted or is recorded on blockchain, it can't be changed. So that's it's what data immutable is talking about. And that makes blockchain transparent and secure. Now, blockchain as computers. What this is saying is that the way a state machine operates is the same way blockchain operates. So, a state machine depends on not only on the inputs to produce an output, it also depends on the current state of the system, which also applies to blockchains like Ethereum. We have key components of a state machine, the states. The computer has different states that determines its actions. Same goes with blockchain. Blockchain has different states that determines its actions. For example, each block on a blockchain contains a snapshot of the entire network state, which includes accounts and balances. So that's the same way a computer works. Then transition rules. A computer has rules that dictates how to move from one state to another. The same way it goes with blockchain. Blockchain has rules that dictates how it moves from one state to another. The rules now in blockchains are written in smart contracts. So smart contracts in Ethereum encodes the transition rules. So input and output. Same way in a computer or state machine, when you feed in input, it processes the input and produces an output. That's the same way blockchain operates. Blockchain will receive an input from users. So these are like transactions from users. The input is transaction from users, and it processes that transactions through the rules that is set by the smart contract and produces an output. Now, on this slide, Ethereum is highlighted because it's the first programmable blockchain. Uh, this is because Ethereum is the first blockchain that allowed for programmability through smart contracts. So not only can Ethereum process transactions, it can also run code that allow developers to create decentralized applications. Now, talking about the blockchain trilemma, the three key features that blockchain introduces is security. This is the ability of blockchain to remain protected from malicious actors, from attackers that are trying to alter the transaction data. So, blockchain provides security against that. Another feature is decentralization. Decentralization means that it is not only one party that is in charge of processing transactions. It's not only one party that is in charge of the data, but multiple parties are involved. So it is decentralized. And scalability is the ability of blockchain to handle an increasing number of transactions and users efficiently. So the trilemma says that blockchain can only fully optimize two of these um, three components at any given time, but not all three. So it can't optimize these three features at the same time. It can only do two, it can only fully optimize two of these features. Early blockchain, many early blockchains like Bitcoin and Ethereum has focused on decentralization and security. Now, there's a need for a technology that will enable blockchains to be able to fully optimize these three features at the same time, and that is what layer 2 scaling solution does. That's what it offers. So the way transactions works on a base blockchain is that when a user submits a transaction on a decentralized application, there's a gas fee that is attached to each transactions, which now gets posted um, to the blockchain network, which is the Ethereum mainnet. Now the issue here now is that when there's an increasing number of transactions that is being posted at the same time to the Ethereum mainnet, it creates congestion, so which leads to higher gas fee, slower transaction processing of transactions, and layer 2 scaling solution solves that. And the way it solves that is that It moves most of the computation and data storage off chain, which reduces the load on main Ethereum networks, and the transactions now happen on a separate network rather than directly on Ethereum mainnet, and this reduces the congestion and gas fees. So the transactions, when they are processed on a different network, uh, the transactions are then organized into batches and hashed using a Merkle tree data structure. So it's now the root hash of this data structure that gets submitted to the uh, Ethereum mainnet. Now, Metis uses this Merkle tree data structure to batch transactions together, and it achieves cheaper transaction by utilizing this Merkle tree state structure. So it's just like instead of posting a huge chunk of transaction directly to layer one, Metis now utilizes these batched transactions and combines everything to just a single group, which is now sent to the Ethereum mainnet. So that is how Metis achieves lower gas fee and a faster um, transaction. Now, the sequencer and the layer 2 network, what is responsible for uh, processing transactions on another network is the sequencer. So the sequencer is the one responsible for um, transaction ordering and batch processing, and we have different types of sequencers. We have the centralized sequencer. So this centralized sequencer means that it's only one sequencer that's in charge of processing transactions, and is the most common type of sequencer used by different layer 2 networks, and they are considered to be more efficient. Another type of decentralized sequencer is the decentralized sequencer. So in a decentralized sequencer, it's not just one sequencer that is in charge of processing transactions. Now we have uh, a set of sequencers. So we have a sequencer pool, and a set of sequencers is used. So decentralized sequencers offers better security, and it is less prone to single points of failure. Another type of sequencer is shared sequencers. So in a shared sequencer, what happens is that different layer 2 networks, like maybe Arbitrum and other layer 2 networks, it, what they do is that they all make use of a single sequencer or set of sequencers. So it is now a shared sequencer, and shared sequencers eliminate redundancy. It allows for a more interoperable, efficient system. Now, MEV means minor extractable value or maximal extractable value, and it's a concept in blockchain that describes the potential profits validators or miners can earn by reordering, inserting, or censoring transactions when creating a new block. So validators or miners can extract value by prioritizing certain transactions over others based on their financial incentives. So for example, now a validator can decide to process or choose a transaction that offers a higher fee before executing a user's transaction that um, offers a lower fee that's part of the same block. Now, sequencers in layer 2 have similar powers to miners in layer 1, in the sense that sequencers can select which transactions to include first in a batch. Now, on this slide, we have a batch of transaction 1 to 4, and the sequencer has reordered the sequence of the transaction in that batch. Now, transaction 4 is coming first, next to transaction 1, 2, and 3. So that is how sequencers are related to MEV. Now, I mentioned earlier that Metis is the first optimistic rollup that has achieved sequencer decentralization, and I'm going to explain how it does that, and this flow chart is explains the architecture of decentralized sequencer. So this is how it happens when a user sends a transaction. It sends it to When a user submits a transaction on a decentralized application using the Metis network. um, it sends the transaction through a RPC node. So the RPC node, which is the remote procedure core node, is the entry point for all transactions on layer 2 network. It is the interface that relays the user's transaction to the decentralized sequencer system. So when the transaction gets sent through the RPC nodes, it goes to the current sequencer in rotation. I said that we have in a decentralized sequencer system, we have a sequencer pool. So we have sequencers that are in rotation. So the transaction gets sent to the current sequencer in rotation, and when the sequencer gets that, it orders the transaction, it batches it and processes it off chain. Now, the POS node, which is the proof of stake node, is responsible for verifying that the transaction is valid. And it checks the transaction status with the sequencer, and the POS layer is a consensus mechanism where validators participate in transaction validation. The bridge and adapter layer is the layer that ensures that transactions move seamlessly between layer 2 and layer 1. So it facilitates communication and ensures that the data is compatible between these layers. So in the transfer of transaction data between different layers, is bridge and adapter layer that ensures that these data are compatible between these layers. Now, after the PS node verifies the validity of the transaction of the sequencer now requests the MPC module, which is the multi-party computation, to sign that batch of transactions. So the MPC is used for securing and signing batches of transactions. So when the sequester requests that from the MPC, then the POS node now checks the transaction signature to ensure the validity of the signed batch by the MPC module. And MPC only allows trusted parties to sign batches of transactions in the sequencer pool deployments. And MPC adds a layer of security for signing transaction batches before they are posted to layer 1. Now, the P2P network, which is the peer-to-peer network, is responsible for sharing transaction data between nodes. It ensures that all nodes have access to the latest information. So P2P network also adds redundancy and security to the process, and it ensures that the network is more resilient to attacks or faults. After the transaction is signed by the MPC and verified by the POS, the verifier now synchronizes this data to the Ethereum mainnet. The verifier ensures the integrity of the sequenced batches before they are posted to the Ethereum mainnet. And on the Ethereum layer, we have the lucky contracts, which ensures that all transactions and batches are secure, they are verified and processed in alignment with layer 1 rules. So this is how layer 2 scalation leverages on layer 1 security. So layer 2 scaling solutions, uh, it offers scalability, which most layer 1 scaling solutions don't have, and it is still secure because it uses Ethereum um, security. Yeah. Now the roll up contracts, we have CTC and SCC. CTC is the canonical transaction chain, and it's a contract that serves as the ordered list of transactions submitted by the sequencer. And SCC is the state commitment chain. This tracks the state of the roll up as transactions are executed, and it allows the system to resolve disputes if any challenges arise about the correctness of transaction execution. So that's the architecture of Metis sequencer. Now, Ethereum and smart contracts. So, Ethereum is an open source, globally decentralized computing uh, infrastructure that executes programs called smart contracts, uh, which are written in high level programming languages and translated into bytecode, which runs on a virtual machine. So, what it's saying is that Ethereum is a decentralized platform built on blockchain technology, and it allows developers to build and deploy decentralized applications, and it also allows for creation of smart contracts, and smart contracts are written in high level languages like Solidity, which is then translated into bytecode and executed on Ethereum network. So now, what are smart contracts? Smart contracts are they are self-executing contracts with the terms of agreement directly written into code. So it enforces and executes actions when certain conditions are met. Smart contract runs on blockchain, and it is deployed on blockchain, so the code cannot be changed. So the thing about blockchain is that once it is deployed on blockchain, it can't be altered. And when the way smart contract works is that a predefined conditions, the rules are coded into the system, and it can only execute these times when the predefined conditions are met. So the predefined conditions are only met when the smart contract executes its actions. A simple metaphor to how smart contract works is the digital vending machine. So when you get to a digital vending machine, you select a product, and it displays the price of the selected product, and you pay the price. Now the vending machine verifies that you paid the right amount for that product, then it dispenses your item. Now, the vending machine will only dispense your desired product after all requirements are met. So, if you don't select a product, obviously you won't be able to get a product. And if you don't pay the right amount of money needed to get that item, the vending machine will dispense it. That's the same way smart contract works. If all the conditions are not met, smart contract would execute the actions you want it to execute. Now, this this slide is talking about how um, decentralized applications works. Is this image is gotten from Talentica, and the decentralized application, what the users see is the front end of the decentralized application, which is the mobile or web app, and it is built using HTML, CSS, or JavaScript. This is where the user interacts with blockchain, with the decentralized application. The client JS library, these are JavaScript libraries like Web3 JS, JS, or other blockchain related libraries, and it is used to interact with the blockchain. So this allows the front end to communicate to the blockchain through JSON RPC calls and perform tasks such as sending transactions, reading data from smart contracts. The wallet serves as a bridge between the user and the blockchain. It stores the user's private keys. It manages the user's cryptocurrency and other tokens, and it basically provides a secure way for users to interact with smart contracts and other blockchain services. Now, the Oracle service is a third-party service that provides real-world data to smart contracts. Since blockchain cannot access data outside its own network, it requires the service of a third-party service like Oracle service to provide this data. An example is when a smart contract needs to know the latest stock price or the latest weather data. So, an Oracle service will provide that data to the smart contract. The IPFS network is the Interplanetary File System Network, and it's a data storage network where non transactional data, such as images, files, videos, are stored in a distributed way. So decentralized applications can make use of IPFS network to store larger data files off chain while keeping the transaction data on chain, which ensures scalability and lower cost. The P2P blockchain network is this represents back end the back end of a decentralized application. The blockchain nodes, they are the one responsible for maintaining the blockchain ledger by verifying transactions, executing smart contracts, and storing blocks. Decentralized applications rely on smart contracts to perform these functions like sending funds, interacting with tokens, and more. And the mobile application does that through the JSON RPC calls. And every time a transaction is executed on a smart contract, the state of the blockchain is updated, and the state is continuously maintained by all blockchain nodes in the peer-to-peer network. So that is basically how decentralized application works. So now we are going to go into the demo on building a decentralized application on Metis. Before I start that, um, let me introduce Lingo to you. So Lingo is a project on GitHub. It's an open source project where different lingos in blockchains are defined. So the basic lingos used in blockchain, the definitions of these lingos, that is what lingo is about. So if you want to contribute to this project, you can just head over to GitHub and search for VM Nuza blockchain lingo. Then you can fork the repo and make your contribution. It is to deploy on the Metis Layer 2 network, and you watched a video on that. Video recorded a video on that yesterday, and you can just recheck that video to verify the process. I'm just going to open the repository and go through the documentation. So this is the repository, and the README highlights everything you need to do, which was what was on the video you watched yesterday. But I'm going to go through it again. Um, for for this um, for this deployment, you need Node.js, Yarn, and Git. You should have that installed on your local computer. And once you ensure that you have that installed, the first process is to clone this GitHub repo. So you clone it on your terminal, and once you are done cloning that, you have to install the dependencies by running yarn install, and that takes a few minutes, from 3 to 4 minutes or more, depending on your network connection. And when you do that, you have to start the local Ethereum network using that you have to run yarn chain. And after that, you run yarn deploy, and yarn starts to view what you deployed on the local host on your web browser using localhost 3000. And once you are done with that, you should be able to interact with the application using add ads. All this process is in the video you watched yesterday, so you can go back to that video to continue your process. And to deploy on Metis, you have to edit your add config to add the Metis network. So copy this and paste it in your add config file to deploy on Metis. Then you also have to run yarn generate to generate your account, and you have to import that account to your MetaMask wallet and send funds to it. So it's either you use the Andromeda network or the testnet network. And for the testnet, you copy the address of the account you just generated, and you head over to the Metis Layer faucet. You paste the address here, you solve this captcha, and you request for funds. And once you get the funds, then you can continue with your process. So, and after that, you have to run yarn deploy to deploy it on Metis. So if you are using the faucet, if you are using the testnet token, you have to run yarn deploy network Metis Apolia. If you are using Andromeda, if you are using Metis Andromeda, then you have to run yarn deploy network Andromeda. Also, you can also check the status of your account by running yarn account on your terminal, and you can see the details about your account on that. And when you are done with that, you can update your front end by going to the scaffold.config.ts to edit the target network. So when you clone the repo, it's change.add that will be there. Let me open that on VS Code. That should be in SJS scaffold.config.ts. So you have to change the target network. I've changed this one now to Metis. So when you are doing yours, it will be change.add that, and you have to update it to Metis. And that's that. When you save that, you can change. Then your wallet will be connected to the Metis network. So all you need to do is to paste your address, the address of the the account you generated. You have to paste that address, and you have to copy that address and paste it on the Metis Explorer. So if you are using the Andromeda network, you go to Metis Andromeda Explorer. Andromeda Explorer. Sorry. Let's just wait for that to load. Yeah. So on the Metis Andromeda Explorer, if you can just paste your address here. I'm going to use a formal address. And when you do that, you should be able to see the informations of everything you did, the contract generation. If you posted a greeting, you see all that there. And what you need to do is to submit the URL of this page. That will be the proof of your contract creation. That will be the proof you are submitting for your to get your rewards. That will be the proof you are submitting. But if you use the testnet token, then you have to go over to the Metis Sepolia Explorer, and that is where you will paste your address. So this is the no, we want to go to the Metis Sepolia. Yeah, so on the Metis Sepolia testnet, then you copy your address, and you should be able to see the details of your contract creation. So this shows that you successfully created a contract on the Metis. You successfully deployed a contract on the Metis network, and what you need for your proof is to submit this URL. So after doing that, the task that is left for you to do is to edit your front end and your back end. So modify the back end and the front end. And once you are done doing that, you can submit your work. That's all you'll be doing. Yeah. Thank you guys. And once again, sorry for the network breakage yesterday. Happy coding. If you have any questions, you can ask on the Telegram page during the office hours.